My view on AI is that the future is massively overhyped, but the current capabilities of the models and what they can do is largely underhyped. AI doesn't have to get better to be useful. You can do things like take a set of construction drawings and extract every relevant material requirement to make your procurement easier. You can cross-check your estimates and bid submissions against the project requirements to look for errors and gaps, or you can set up an analyzer feature in your inbox to track and flag any important commercial correspondence that you might have missed. Maybe these are useful applications for you, or maybe they're not. But with a little bit of creativity and effort, I am 100% sure that you can find useful applications for AI to your construction business. Does that mean you should be using it to prepare estimates without checking, or rely on it to write an important email to your clients? Well, no, of course not. It hallucinates, it misses context, and it has some important limitations like being able to read and understand construction drawings properly. We need to be strategic with how and when we apply it so we're playing to its strengths and we're not falling into its weaknesses. My goal for the video is simply to answer the question, how can you become an AI-first construction company without focusing on these over-exaggerated future use cases and finding realistic, practical applications that actually save you time and money? How can you make use of potentially the most transformative technology since the internet? Now, maybe I overhype AI and I've fallen into the trap, but you can make the judgment for yourself. This video is really just going to be all about giving you a practical definition of what I mean by AI first and using an integrated approach to adopting AI versus an ad hoc approach, where it makes sense to apply AI and where it doesn't, different ways to use and apply AI that can be through chatbots, software, or automations, and specific use cases and operational applications of AI. We'll look at everything from accounting to estimating to project management, and again, where it actually makes sense to apply AI. And then finally, I'll talk about the foundations or core principles like structured data and an understanding of the fundamental project management processes that you need to actually make AI useful. Okay, so first, I want to define AI first, and I want to put the brakes on the hype train. AI is and never will 10 times your business. It's not going to fix the inherent problems in the construction industry like largely commoditized services and a race to the bottom market, brutal contracting and cash flow positions, and it's not going to solve aggressive bad clients and bad project managers and employees. The construction industry has real constraints to grow, and intelligence was never actually the constraints to most construction companies to begin with, so it's not automatically going to be the solution. So maybe it's not the core constraint, but intelligence does constrain operational performance. Think about this. If you had 100 or 1,000 project managers that could work for you for little or no cost, you would likely get better results on your projects. Now, there's obviously a law of diminishing returns, and it's not as clear cut as if you had 100 or 1,000, you get 1,000 times the results, but you would be able to perform the core project management, project controls, accounting, all these functions much more better and effectively. It doesn't solve problems like running into unexpected ground conditions or going for a project when you have a competitor who's significantly underbidding. But projects run well versus projects run badly can have significantly different financial outcomes. A bad estimate can bankrupt a construction business, a missed claim will lead to lost revenue, and incorrect material orders will delay projects and increase costs. Now, these sorts of mistakes are not 100% preventable with AI. I'm not making the promise that they are, but we can begin to build processes where we add more and more intelligence to them to reduce the chances of things like this happening. The way I see the role of AI and how to think about applying it within a construction business is, what are the important tasks you know you should be doing or would do if you had more resources? For example, spending more time reviewing your estimates or reviewing your contracts before you sign them, or maintaining a detailed correspondence register with the client, or even stuff as simple as every time you have a meeting with a client or a key subcontractor, you take meeting minutes and note them down. So coming back to this definition of what I actually mean by AI first, well, I define it as applying intelligence to tasks where previously it wouldn't have been economical to do so. If you're a construction business, a small contractor, you probably can't allow for 7 project managers and project engineers on a small project. Your overheads would mean you never win the work, and if you do get the project, you wouldn't have the budget for them. But using simple tools like AI, where it's integrated into software, or setting up your own automations, you can begin to start to chip away at some of these important tasks that historically wouldn't have been economical to do. Really, I see the role of AI as not necessarily fundamentally reshaping the entire way we manage a project, but just being able to do the fundamentals better. And to do this, I come to the ad hoc versus the integrated approach. To reliably do this, we need to better integrate AI into our processes, not just ad hoc and randomly use it. Everyone uses ChatGPT to draft emails, ask questions. It's become a surrogate Google search. This isn't an AI first or an integrated approach. This is just randomly ad hoc usage, which isn't bad, but it's the same thing everybody's doing. So an integrated approach to using AI would be having AI contract reviews integrated to your tendering process. So every contract, before you sign it, AI extracts key terms, compares them to your standard terms and conditions, flags departures, and generates the first draft of your departure register and identifies any key commercial risks you need to budget for in your estimate. A human then reviews the output, and it's not an optional step, it's a fundamental part of your process. It's integrated into the process. So to find use cases of where it makes sense to integrate AI into a process, we need to understand what it's good at and what it's bad at. So later on, I'll talk about the specific tools and the specific domains where you would apply it, but just generally, AI is good at summarizing and distilling large documents, first drafts and generating registers, checking and verifying outputs, for example, cross-referencing and checking your estimate against the bid requirements, pattern matching, so comparing contract terms, and processing huge amount of volume without taking or costing a huge amount. Now, that's what it's good at, but what about what it's bad at? Because understanding what it's bad at is essential to understanding where it actually makes sense to apply. So AI is not good at specific judgment calls. So things like, should we take this job? Should we not? In this situation, would it make sense to accept liquidated damages, or should we push back on them entirely? It doesn't understand inherently business risk or the context behind it. The next limitation of AI is actually getting it to stay current and up to date with your information and context. Obviously, AI can't go walk around the construction site. It can't call subcontractors and suppliers, can't go through your project documents or find some obscure file. It's fundamentally got a knowledge cutoff in the actual training model, but then also, unless you connect it to your tools and your documents and your background information, there's always limitations to what context it actually has, which is always going to limit its ability to do tasks. The next challenge we all know about is that AI hallucinates. It can confidently make stuff up. It can be fundamentally wrong about things in a way we don't understand or we would think is completely nonsensical, but it wouldn't necessarily always come up with AI. The next one is tool access. So we can log into software, use it, unless software is specifically designed with either API or MCP access, so AI can natively integrate with it. A lot of the time, it just can't use the tools we need it to do tasks. So for example, now you can integrate your Google Drive with Claude or ChatGPT, but specialist construction software, like for example, TeamBinder and Aconex, don't have these native AI integrations. So if you actually want them to do a useful task, which involves updating some sort of register in a software, it's not physically possible to do it yet. The next limitation to understand, which is a bit more nuanced, is visual reasoning. AI can extract text very well, but it can't necessarily process images in complex construction drawings. So something we might actually think of as quite simple or intuitive, like tracing a conduit from one drawing to another, is almost impossible to get AI to do. And then you also just have to be aware of the obvious task limitations. A lot of the time when we're doing construction work or construction management work more specifically, a lot of it is like calling people and getting information. AI can't do that. It's any time you're getting information from other people, working with other people, it's like AI can't do it. So it's obviously so limited by the fact that it's stuck in a computer, can only do computer work, which really is probably, for project engineering roles, probably only 50% of the actual job. The final point I'll make is the security and particularly data security limitations. This is both in terms of the actual security. For example, if you give AI access to your emails, it could go and delete a whole lot of things. It could send emails you don't want. So there's obviously the security and reliability, the actual task it's doing and the risks associated with it doing the task badly. Then there's also the data security. Sometimes you'll be working on projects and your clients will give you confidential information in the contract you sign with them. There'll be specific clauses in there about maintaining data security, not uploading it to the internet, these types of things. If you're using AI, particularly if you're using the chat interfaces like ChatGPT and Claude, they actually train on your data. So you probably find you're violating your contracts by doing this. So you have to be just really have to be aware to the data and security concerns around using AI. Okay, so this leads us to the sweet spot of AI uses. Clear inputs and outputs, definable rules to follow, human verifiable outputs, and limited risk. A task should have a clear trigger, start point, and end points. When output it does, it should have rules or a system you get it to follow. You should be able to verify the output. And the limited risk, what I mean by this is that if it hallucinates, if something goes wrong, it's not catastrophic. So for example, AI preparing an estimate, I think is a bad use case of AI because there's just so much money on the line. Even if there's a low probability that it hallucinates, hallucination would be an absolute disaster in that situation. But using it to maybe prepare a budget estimate, which isn't a firm contractual commitment, could be a good use case. Or using it to cross-check your estimate as an additional layer of security, that is a good use case of AI. Okay, I want to stop the video here and bring up what I think is an important point and something that is becoming increasingly obvious to me over the past months where I've been working a lot with construction companies to implement AI. Implementing AI is actually quite difficult. So sure, using ChatGPT, Claude, prompting it, all that stuff is relatively common sense. But actually building AI into a system like an automation is something you should do. It does make sense to do it, but it takes a massive investment of time and resources. For example, recently I was working with an electrical contractor to implement an AI document control system that triggered automatically, took information when the client sent it to them, stored it in the folders. And we're just progressing down this path of the system getting more and more complicated. All these integrations into the automation, just getting increasingly complex. And partway through, I just came to the realization, you're way better off just getting someone on Upwork, hiring an engineer overseas if you're in the US or Australia at a fraction of the cost of what you'd have to pay someone in Australia to do this for you. Pay them to do it one day a week, and you will get a result that is probably 10 to 100 times better than an AI system. Finding good people on platforms like Upwork is, I would say, an unbelievably underrated strategy. So yes, some situations it makes sense to apply AI. Other situations, it would make sense just to outsource the task to overseas. And sometimes you'll find that the AI equivalent of that task is more expensive, less reliable, and less customizable. For example, I've been looking into AI quantity takeoff tools, and some of the pricing I've seen from vendors is like 20 or 30 US dollars per drawing. And they don't even claim to be 100% accurate. Like, you could probably get somebody to do a takeoff on a drawing for a quarter of that cost, and it would be 100% accurate, or as accurate as it could be. Okay, so how can you actually use AI? Well, there's really three interfaces through which you can use AI. Number one, the one we're used to would be a chat interface. This would be using something like Claude, ChatGPT, or Gemini. This is sort of good at ad hoc questions and queries, document Q&A, particularly if you don't use Gemini, you use Notebook LM, and you can actually get AI to respond just on your source documents. You can use it to prepare first drafts, or for example, here, I was using it to cross-check an estimate I prepared, and then based on that information, I then got it to create a schedule based on the data in the information. So there's lots of different use cases here. If you're thinking about this, it's very easily customizable to exactly what you want it to do. I think it's good at when you connect it to a database. So when you actually connect it to sort of like a Google Sheet where it's got your source information, it can pull and use that. And it's good for brainstorming. Now, where are these tools not good? Well, they're not good at consistent and repeatable tasks. Say you want it to prepare a project management dashboard. Claude, you can create quite nice user interfaces, but every time you get it to pull your data and create a dashboard, the dashboard will be slightly different. Now, there are ways to overcome this that I'll talk about, but it's not good at consistent, repeatable tasks. They're not particularly good at integrating into tools, although they are getting much better. Now you can quite easily connect things like Notion, Drive, or Airtable. A lot of the big apps allow you to connect them directly to Claude and ChatGPT. They also don't allow you to automatically perform tasks. Prompt in, text, or document out. Can't automatically trigger them to run. Well, ChatGPT you can, but the way it works, I don't find that useful. Other way you can actually use AI is to integrate it into an automation. So automation software, if you're not familiar with them, the things like N8N, Make.com, or Zapier, and that's basically where you can connect AI into a system. This is good for repetitive workflows, data movement, or triggered actions. All right, so if I show you a little example of what I'm talking about, this is an automation to generate a progress report every week that just summarizes where we're up to, what percent different tasks are complete. It runs weekly, so it's triggered by a schedule. It finds the relevant data in Airtable, so it gets all your progress reports and information. It structures that into a progress report using AI. So this is where AI is integrated into the workflow. Then it sends an outbound email to the client. So it says, this week we did 500 meters of trenching. We're 30% complete. We laid X meters of conduit, blah, blah, blah. So it's just basically every week running an automated progress report to keep our client informed. So where do automations fall over? Well, any sort of complex decision-making stuff, obviously automation is just a set series of steps. Any complexity or nuance to this, it's not going to work. They often have more of an initial setup complexity. Although Zapier is unbelievably easy to use, they do have some initial setup complexity. And again, it's just constrained to the workflow. If you want to do something that falls outside of the workflow, you either have to adjust the workflow or it's not going to be possible. The next way to use AI is to use pre-built integrations other people have done in software packages we use. So Procore has AI integrations. All the big construction management softwares are rolling out AI integrations. This is an example of where I've used AI in my estimating and contract management software. Basically, what it does is you upload the scope of works and the drawings. It analyzes that, extracts all the key quantities, does a summary of all the drawings, extracting all the relevant pricing information, turns that into a list of requirements. So every pricing requirement that you need to capture in your price is structured and put in a list, gives you any discrepancies between the drawings and the scope of works, any RFIs or clarifications you should ask, and it does a simple risk and opportunity analysis. So this is an example of taking a set of bid documents, turning it into a report, telling you what's missing, what you should clarify, what the risks are, extracting the key quantities from the drawings to make the estimating process easier. So that is done using AI, but you don't have to do any setup. It's purpose-built functionality. Someone else has already set it up, tested it, made sure it works. It's much easier to scale, and generally the security and data requirements are much better. And I mean, every one of these companies has security and data policies that you can easily check out and read, but the data in software tools, generally, depending on what the specific vendor says, they'll protect your data, but not using your data to train future AI models, which things like ChatGPT and Claude do. Now, the negative to this is this won't reflect your unique workflow. This is just a standard way of doing it that is captured in the software. You might have a different way you want to do it. You obviously have to pay for the software. It's probably going to be more expensive than just using ChatGPT or Claude directly. You potentially have vendor lock-in depending on what sort of data you're inputting and how much complexity there is in setup. For example, once you start using an accounting software, you're not going to change midway through the financial year. Software obviously has some sort of limited flexibility, and then there's always the learning curve. Like you have to learn how to use a new software. Okay, next up, I'm going to fly through and talk about some AI use cases under different domains like accounting, estimating, design management, project management, so on and so forth. I'm going to list out software applications that have done this, but obviously you can actually go and get these software, or you can use them as inspiration for something you want to do. Now, again, the specific use case for your business might be different. My rule, I think it's good to look at what other software vendors are doing because it gives you inspiration for what you could do yourself. And it shows you what is actually technically possible. But really, for you to identify use cases, you just have to get good at identifying problems, having some understanding of AI and understanding how the technology works and where it actually makes sense to apply. All right, so accounting applications in construction, I see sort of fit into two buckets. You've got your making what you already do now easier. For example, you could get a big confusing invoice from a supplier. An AI invoice processor can extract the relevant pricing information from it rather than you having to manually go through the invoice. You can do this with like Gemini or Claude, or I use LumParse a lot, which is a specialist AI parser. The other category of applications in accounting are things like predictive cash flow forecasting, where you take as input the budget, the schedule, payment terms, and it uses to generate a cash flow forecast. So I think that's a good application of AI. Pretty sure this software does it, although I haven't actually played with it, but it just helps you to get better hold on your cash position. Then you've got estimating and quantity takeoffs. Obviously, this is the area I'm super interested in and what I've spent a lot of time on. You can get automated quantity takeoffs. Again, the software that I've seen claims to be specialists at this are insanely expensive, more expensive than getting an outsourcer to do it, and they don't claim to be 100% reliable. The way I focused on this use case is I use AI to extract an indicative bill of quantities and doesn't claim to be correct. So I qualified that it's an indicative bill of quantities only, which I think is good for this use case of generating first pass estimates and budget pricing. Would I get AI to actually prepare an estimate for a lump sum $2 million contract? No, because there's way too much on the line. It's not a good use of AI. But I think the other use case I really focused on building into my software was using AI to cross-check your estimates for errors and gaps. Then again, you've got tenders and contract management. I've done a more detailed analysis of this on exactly how to review a contract with the AI. Again, if you just upload a contract into AI and get it to do a summary of the key terms and conditions, they actually just do a very good job. You probably don't even need specialist software for this, but I have a specific process I like to go through to review contracts with AI, but contract reviews is a very good use case because they're just a big pattern matching exercise. But you can also get them to analyze your tender documents, like the example I showed you before, where you're looking at extracting all the pricing requirements to compare them to your estimate, helping you to identify risks and opportunities. So I find the artifact feature in Claude very, very useful for this type of thing, but you can take your project documents and you can get Claude to generate a Gantt chart in the specific UI of a Gantt chart. So no more manually highlighting bars in Excel, getting it to make some pretty Gantt chart. And every time you adjust something, you adjust it. Claude can now very reliably just build Gantt charts, and then you can just type and text to adjust them. So when that's run, I'll actually show you what it looks like. But some other use cases for scheduling and is obviously creating schedules with AI, optimizing schedules, risk forecasting, risk leveling, schedule recovery plan. I saw this company called Enplan. They have basically trained their own AI on over 750,000 projects. So obviously, ChatGPT, Claude, things like that, they are trained on all the data on the internet. But Enplan, interestingly enough, is trained on 750. I don't know how they got 750,000 projects, but they are trained on basically a whole custom data set, and they will pick up specific things where they know adds risk to projects. For example, I spoke to someone from Enplan the other day, and they were telling me they have found this really interesting link between, I can't remember exactly what it was. It was something like the duration of the piling program and the early works excavation before it were linked. There was just these really interesting insights that they had picked up, again, because they have a proprietary data set. They trained it on specialist scheduling. They trained it on a lot of different schedules, so they can give you much more accurate predictions and insights about risk. The next category of tools I've been seeing come to safety and compliance. They claim to do things like real-time hazard detection, and basically the general way they seem to work when I was looking at this one is they set up cameras around the site and they use computer vision to monitor things like people wearing PPE. Now, what I've seen in my experience is if you set up a whole lot of cameras around a construction site and start monitoring what everyone would do, you might solve safety issues, but you will create industrial relations issues. So look, maybe some of these are good for big companies that have huge budgets. I couldn't necessarily see the use cases of some of these software for smaller contractors. I would say I actually spoke to someone the other day and they had a very interesting use case of AI and safety where they'd basically done 2,000 toolbox talks. So not toolbox talks, they'd done 2,000 job risk assessments, and they basically used all these toolbox talks and created a massive database of all the risks they were exposed to, the most common risks they were exposed to, and then use that to plan their toolbox talks, which I thought was a very interesting insight because basically, again, it's probably not going to change your construction business dramatically, but it's just an example of one of those little 1% gains where they made the toolbox talks more tailored to their work. And that was a data-driven insight. Again, to get someone to manually go through all those handwritten notes would have taken a lifetime. That is a very good use of AI. Now, quality in completions, again, the principle was very similar to what I saw with the safety compliance, where you relied on computer vision and monitoring construction sites. I mean, again, I don't think that's the best use case. I think setting up cameras and watching people work is something that will fundamentally cause industrial relations issues because workers won't be happy with being watched whenever they're working. But I can see the benefits with things like quantity verification. You could potentially get installation accuracy. I think where you do get benefits with quality and completions is you can do things like document verification. So comparing how drawings change from one revision to another, making sure that downstream documents aren't impacted. For example, if you get an RFI, does it impact an ITP? Those are checks you should be doing, but probably don't do. The other use good case would be similar to the example of the toolbox talks is you could look at all your historical defects and then you could actually identify ways to improve the performance of the works going forward by identifying what are the key quality and defect issues you run into. Again, the reason this hasn't been possible in the past is if you think about a civil construction project and you have defects with a structure, on 10 jobs, they might use 10 different words to describe that same defect or 10 different sentences. In the past, it was impossible you would have had to pay someone to manually go through every single defect and categorize them. They'd have to come up with reasonable buckets. And then you probably lose some sort of detail when you're going through this process. But you can use AI to do that now. That sort of large data set analysis is a very good use case. Then we've got project management and coordination. So things like document search and retrieval, generating RFIs, tracking change orders, progress reporting. This is an AI construction management platform called Mast that you can create project dashboards. So you can type with text, you can upload your project documents, and then it will actually create a dashboard for tracking performance based on the schedule, the budget, these sorts of things. So it's just making your job of creating dashboards something that you probably know you should do but aren't doing easier. Okay, so those were example applications across each of the core domains. Some of them, maybe they're useful for you. Some of them maybe are not. The next part we need to talk about is how do you actually get the most out of AI? So the number one most important thing you can have to get more out of AI is data. What do I mean by data? It's using your information, your historic estimates, your historic production rates, your specific project information as context when you're getting AI to perform tasks. AI is simply trained on all the data they scraped from the internet. If you want AI to produce an estimate for your project and you give it no additional information, it will give you a terrible generic answer. But if you want it to actually produce an estimate the right way, you need to give it the drawings, the bill of quantities, the specifications, your costs library, your historical production rates, all the different costs you incur for different labor plant materials, subcontractor quotes, and any constructability constraints. If you give it all that information, all that data, you'll get a better outcome out of it simply because you've given it more context. So foundation number one is going to be structured and easily accessible data. Now, I've sort of already covered this point to death, but foundation number two is good use cases. Not everything benefits from AI. You shouldn't be looking to apply AI to your business. You should be looking to solve problems. Sometimes AI makes sense to solve those problems. Sometimes it doesn't. AI is good with tasks where intelligence is the bottleneck, things that you've done poorly because you couldn't justify the time, things not done at all because they're too time consuming and you don't have the budget for your overheads to manage them, high volume, repetitive tasks, and pattern matching against known standards. This is a bad use case of AI. There's a lot of money on the line when you prepare an estimate. It's hard to give it all the context. It's not going to end well for you if that's how you're using AI. Now, foundation number three is good guardrails. AI can make confident mistakes. We know it can hallucinate. It won't necessarily flag you if it's missing context. So every AI workflow should have human verification that's maybe not always going to be as simple as going through the entire work that AI done, because that would just be double doing, but having ways to check the output, being able to make sure it made sense. For example, again, you get AI to prepare a budget estimate. You should have another quick parallel way to do budget pricing to understand whether the answer makes sense or not, some error checking mechanism, or validation against known data. So some examples of where a human would be able to catch error is if you get AI to extract the contract terms, a human reviews them before signing and submitting it. AI generates an estimate, a human does a sanity check of the cost, AI flags correspondence risk, the human decides whether to take action on it. Foundation number 4 is automation. So having an understanding of how to automate different tasks and where it makes sense to apply intelligence to it. So this is basically, say you want to build an invoice processing system. How does it start? What's the trigger for it? Is it an email being received? Is it uploading a file to Google Drive? What is the data processing? How do you want to extract it? What is the output format you want the data in? And what is the output action for the task? So having an understanding of how to automate a task, not necessarily with AI, but just a good understanding of automation in general and how automation tools work, will give you much better applications. The last 2 foundations is understanding limitations, understanding where it's more difficult to give the AI enough context than it is to do the work yourself, understanding what tools it's possible to give it access to, what tools you can't, understanding the hallucination risks and what actually underlies and drives them, understanding how and when it can process visual information. So for example, I know AI can do good quantity takeoffs if it is counting something like light fitting using the text tag, but I know it will do a terrible job at measuring a conduit that goes through a wall where there's not explicit measurements on the drawing. So building an understanding of the limitations and working around those limitations. Now, the final one is understanding privacy and security rules and regulations about how you use it. If you sign a contract, it likely has in there IP or data security information, or potentially even a non-disclosure agreement. That means you wouldn't be allowed to upload the data to unsecure servers or to things like ChatGPT where they're training on your data. So you just have to pay attention to the tools you're working and understand the privacy and security implications of what you're doing. Okay, I want to wrap up with 3 simple rules about how to actually go out and start doing stuff with AI. Number 1, start small. Pick a very niche problem that you can quickly solve in the simplest way possible. Don't try to do the most complicated system ever. Start very small, very simply, and solve the problem. Basically, if you start where there's pain or time consuming or waste, that is a good place to start. But pick one problem, pick a small solvable problem. Then choose the right tool for the software. Choose the right tool for the problem. Maybe software makes sense, maybe a chat interface makes sense, maybe an automation makes sense, but I would say automation would probably be more complicated. So you'd want to start with either a chatbot or a pre-built software, then do a pilot project, measure the ROI, see if it's actually saving people time, reducing errors, whether there's cost benefits, and then refine and scale it. So start small and then scale it. We know to do this effectively, you're going to need some sort of structured data in context that you can easily give to the AI, a clear use case where intelligence is the bottleneck, guardrails in place, so some human verification process, some automation capability if you're doing an automation and to know the boundaries of it. And then again, just measure success. It should result in time saving, error reduction, safety improvements or quality gains, or a happier customer.